webinar. You have entered as an attendee in listen-only mode.
Nice security distro, very flexible, Android, Ubuntu, Windows 10, Server 2016. So what happens is we come up with a variety of scenarios for you to hack. That's right. So this class is meant to be an offensive class. I'm not talking about offensive like, oh, I'm so offended. No. I mean, we are on the attack, right? So you learn to scan, you learn to find vulnerabilities, you learn to do SQL injection, you learn to do malware analysis, you learn to do session hijacking, you learn to do all the things that we saw in those 20 parts of the class. And by the time you've finished your focus on it, you'll be a fairly good hacker. That's what it is. If you actually work on the labs and on the other courseware and the other things that we provide. So yeah, if you look over here, iLabs. That's the kind of a representation of how iLabs looks. This is how it actually looks. Here, let me bring it over to the other screen. There it is. This is iLabs. In fact, this is some of the stuff we're going to be working on in the rest of the webinar. You'll find that there are multiple modules, multiple labs, and this one has 4 labs in it. But check this out. Let's just go to lab 2. Lab 2 has multiple tasks. So privilege escalation using escalation tools, client-side vulnerabilities. Over here, we go down another one. There should be another task right down here. All right, almost there, 45. Maybe this. Here it is. There's the second one. Hack a Windows machine using Metasploit and perform a post-exploitation using Meterpreter. And so you have 2 tasks in this one. The one before, these are 2 long tasks. The one before has about 5 or 6 tasks in them. So it's a huge collection of exercises. And one of the things that I like the most about these labs is that they explain to you step by step how to do the tasks. I'm gonna demo this in a little while and show you how it works. But that is a cool deal. And the reason why I like that so much is because it teaches you how to do it. And then what you can do is you can try it out for yourself later on. You learn how to do it, and now you can try it out for yourself, which is really cool. So when you take the class, you have access to the labs for 6 months. So you have plenty of time to get familiar with all of the topics and learn how to hack. It's really, really cool stuff. All right, wrong button. There we go. So also, as an option to the CEH, we have what's called Break the Code. And Break the Code is an environment where you can take things like SQL injection and cross-site scripting and scanning enumeration and vulnerability analysis and even server-side request forgeries and so on. You can practice that in a lab. So what will happen? Well, first of all, you see here it's a 24 incredible hacking challenges across 4 levels of complexity, 18 attack vectors, including OWASP top 10. It's part of the gamification. It's a gamified platform that's an add-on that you can do if you want to CEH. This is just a screenshot of the Break the Code. This is I was about to get in there and run through, starting at beginner, right? Start at beginner. There's SQL injection, there's security misconfiguration, cross-site scripting. So what you do is you go find what it is that is the problem and then hack it. And if you've gone through the iLabs, then you'll have some idea of what to do. And one of the problems with it, and I say problem in quotes, is that you have a limited amount of time, like 15 minutes, right? So if you have to do the SQL injection, you bring up the UI, and once you get in the user interface, you have to evaluate what you have and then try the SQL injection. So yeah, lots of very cool stuff We also have another very nice, this is free, and you can try it anytime you want. In fact, if you want, you can open up a tab and go on over to HTTP, not HTTPS, www.certifiedethicalhacker. Certified hacker, not ethical, certifiedhacker.com. And inside this site, there are multiple websites, and they are there for hacking. So you can scan them, enumerate them, and you can try various attacks, like, for instance, injection attacks, like I was talking about before, code attacks, things like that. So yeah, this one, you can do this anytime you want. This is live, free, anytime. So what happens is once you get through all that, it's time to get certified, become a certified ethical hacker. And so there is a 312-50 exam that has 125 questions. You have 4 hours. It's a knowledge-based exam showing that you know what it takes to be a certified ethical hacker. Once you pass this exam, it does require extensive knowledge of the core modules. Once you pass it, oh, by the way, that's version 11. I need to fix that. Once you pass the exam, then you will become a certified ethical hacker. But there's more, because there's also the practical credential. It's a 6-hour exam. What I recommend when you take it is take it like in the early hours of the morning. That way you can get out with still some day left. Our CPENT exam is a lot longer than that. 20 real-life scenarios. And in this one, you're not just answering a question. You have to demonstrate that you know the technique. So you have to actually go into the user interface and do some hacking, right? And there are proctors watching you to make sure that you are actually finding the answer. So check this out. Here's a question that's sort of typical of the practical credential. So during a security assessment, it was found that a server was hosting a website that was vulnerable to a certain certain types of web attacks. Further investigation revealed that the underlying database management system of the site was MySQL. Determine the operating system of the machine that hosted the database. How do we find? So there's some machine that's running MySQL. How do I find that? Well, what I do is I start my scans. So over here you see that they're using ZenMap, and very likely they're running a Windows box. So I would probably use the Linux box and use Nmap. And what they're doing here is they're running a scan for port. See that -P right there? 3306 on the entire subnet, and then they're finding one machine with that port open, 3306. And then what we do from there is we do a further scan on that machine, maybe with a -A or something like that, and bring up the operating system, or maybe a -O, and find the operating system of that machine. And then from there, we can choose the correct answer. It's hard to see, but if you look way up here at the upper right-hand corner, see where it says exam on this first tab on the left? That's where the actual exam questions are. And then the machines are over here. They don't show you the rest of the network. You're going to have to do scanning in order to find that, which is, I think, really cool. Once you pass both the written, the knowledge-based one, and the skills-based one, the practical, you'll become a master of hacking skills, and you'll earn the credential CEH Master. So that's pretty cool stuff. So anyway, that's some of the introduction to the Certified Ethical Hacker. Now let's get into the first look itself. And what I want to do is show you around, for starters, Module 6, which is system hacking. And Module 6 covers quite a lot of stuff: the methodology, gaining access, escalating privileges, rootkits, all kinds of stuff. It's a lot in here. So let's just start with some of the concepts of system hacking. And I want to do a quick throwback to what we were doing before. If you look over here, leading up to this module, we really went through the first steps of the CEH hacking methodology, or the CHM. The CEH hacking methodology starts with footprinting. With footprinting, you find out as much as you can. So let's say that after becoming a certified ethical hacker, after getting that certification and passing maybe your CEH practical and knowing all this stuff, you get engaged as part of a team to attack an organization that needs to have penetration testing done as part of their normal course of business to make sure that they don't have extreme vulnerabilities. But it's a black box pen test. They don't give you a lot of information about the organization or about the network or anything. So you have to go out and you have to find this information yourself. Maybe starting with LinkedIn and looking at who runs that organization, and then going into and all the employees and so on, and then going into sites that will give you information about their DNS that they own, and maybe you go outside the organization and do some dumpster diving and find out stuff they threw away, and get some information about the organization and what they do and how they do it, and after a while, you can get IP addresses, external IP addresses they own, and then you can begin scanning the external network. Maybe based upon what you find, you can begin scanning the internal network, map it out, find out all the live hosts, their firewalls, their intrusion detection and prevention systems, all that. Then you find that maybe there's a web app behind port 443 or behind port 80, or maybe there's a MySQL or a Microsoft SQL server or something like that, or some other type of protocol. Maybe they have SNMP or SMTP. And so you enumerate those protocols, pulling out usernames, pulling out more IP addresses, pulling out more apps, verifying that you match the employee names that were in LinkedIn with what you find with your enumeration. And maybe even you find more than that. Then in the process of doing all that, you find that there are vulnerabilities. And sure enough, they've implemented some of their apps with some errors. There's a problem with a couple of the servers in their data center. There are some of their hosts that don't have, they're not fully patched. So we find that there are vulnerabilities. So now guess what we can do? After doing footprinting, scanning, enumeration, and vulnerability analysis, we can hack the system. So there are several major areas that we do with system hacking. One is the actual gaining access. So that would be cracking passwords. Maybe taking one of the vulnerabilities that we found and exploiting them. Escalating privileges. Then we want to maintain access. So now that we have one node on the network compromised, why not try to get more? Why not bring in some tools from your command and control services and use one of those tools to hack more? Why not take the information that you found and hide it and exfiltrate it, and then go back through and cover your tracks so nobody knows that you're even there? And then you become an APT, an advanced persistent threat, working with your team to pen test an organization, find their vulnerabilities. What we find is this is the exact methodology, for the most part, that attackers use. And it's good to know it. And that's what we're studying in this class. So in that first part, right up here, where we see gaining access, let's look a little bit further at that. And we see that gaining access, there are many ways to do that. Crack passwords, exploit vulnerabilities. One of the things I like to tell my students is, frankly, a lot of what we talk about, all the different hacks and methodologies and so on, they don't work. Why? Well, most people, when they implement networks and computer systems, try to do it as securely as possible. So most of them won't work. All it takes is one, though. If one works, then we're in. And I like to say, if you can't find one of these techniques that work, then if you can't find anything that works, just ask somebody. Yeah, this is Fred with the accounting department, and for some reason, I was told that I was going to get a new account for a new initiative, and I don't have the new account. Can I get the new account, please? You're getting a new account? Yes, it's just a user account. I just need to get it done right away, and then just send me an email, right? Or you fake like you're a consultant or whatever, and you can get a whole new account, or you can get a password change, or you can get information about the organization that will lead to an exploitation. You can exploit vulnerabilities. We'll talk about that in a little while. Bring in applications from your command and control services to create and maintain that access to that system. Maybe you're going to bring in backdoor software, keyloggers, hiding files with rootkits or steganography, or clearing logs by deleting the logs that normally would have followed you and revealed the fact that there was an attack. But no, you deleted it. All right, so now that's some of the concepts we're going to talk about gaining access. Now, I don't know, have you ever met Sam? Oh yeah, Sam, the Security Accounts Manager. If you've ever logged into a Windows workstation, ever used a Windows workstation, Windows laptop or whatever, you have met Sam. The Security Accounts Manager is the way that passwords are stored on standalone Windows workstations. And it's also a way that we hack them. Makes them very vulnerable. One of the problems with the SAM is NTLM. NTLM is a way of authenticating that uses obsolete hashing technology and allows us to crack those hashes, which we'll see in just a little while, and get into the workstation. You know, this has happened several times to me. Somebody comes to me with a laptop and like, I changed the password on Friday, and then I partied all weekend. I can't remember what the password was. I can't log into my laptop. Can you help me crack into it? I'm like, oh yeah, I can do that for you. It's because of the SAM. Or I haven't used this desktop in a year and a half. It's just been sitting in an old bedroom or in the garage or whatever. But now I need to use it because my kid's moving back home and I can't remember the password. Can you help? Oh yeah, we can hack that for you. Go grab that password. It's very easy to do because of the fact that the SAM is so crackable. Then we have another type of authentication called Kerberos. Kerberos. They updated in the year 2000. I remember it very well. And when Windows 2000 came out, and they had thrown away NTLM authentication and brought aboard Kerberos. We'll look at that in a moment. And it makes it much more difficult to attack the system if the organization has done it correctly. So that's Microsoft authentication. But look at this. This is, if you go to C:, whack Windows, whack System32, whack config, whack SAM, you will find the SAM database. And in the SAM database, you'll find the hashed passwords using an NTLM hash. NTLM is very easy to break. And we'll see that. I'll demo that in just a little while. If you look over here, this is the NTLM authentication process. So you have two devices. They're going to be working together. This is not a domain controller, but some type of server or another client that you're interfacing with. And what they do is they will exchange hashes. And it is those hashes that we can crack. Now, if this was a Active Directory domain controller, instead of exchanging hashes, which are easy to crack, it's a much more sophisticated methodology that's used for Kerberos authentication. The Microsoft Domain Controller is also what's called a Key Distribution Center, or a KDC. The purpose of the Key Distribution Center, one of the main things it does, is hand out TGTs for this ticket granting server. So what'll happen is this client will say, hey, yo, KDC, Active Directory, I need to use resources on this network. Please issue me a ticket granting ticket. And based upon the authentication that happened previously, this client will be granted a ticket granting ticket. There's an entire exchange that happens to make that possible. This client will then go to a resource like an application server or a file server that is sharing a resource and say, hey, yo, resource, I want to use, get into the folder. I want to use the application. I want to use the printer, whatever it is. And the application will say, do you have a ticket granting ticket? And the client will present a ticket granting ticket to the application server or the whatever is serving up the resource. And it'll say, good, that looks like a good ticket granting ticket. Therefore, I'm going to give you a ticket. And the application server gives the client a ticket that will allow access to the resource. So it's a lot more sophisticated. And as you see, there's never been a hash exchanged in all of this, which means that it's a lot more secure. But remember something about Kerberos. Kerberos, when Microsoft took it, they made it a little bit more secure, and they made it something that works specifically with Windows. But Kerberos is in many authentication systems. And so learning to hack Kerberos is actually a pretty good deal. Another thing we want to do is be able to crack passwords, recover passwords from computer systems. Really helps us. In EC Council, we have this thing called the EC Council Storm. It's a little portable hacking device. So typically what I'll do, take it behind enemy lines. So if I'm working with an organization or doing a demo or whatever, and allow it to pull down the hashes. So with Wi-Fi, or if I have it connected to a network where I can actually find hashes. And then I exfiltrate those hashes to like an EC2 AWS in Amazon Cloud or something like that. Get a Linux box where you put the tools that you need to crack the hashes. And then you run it there and take use of their extra computing power, crack the hashes, and then from there you have the passwords that you need. So there are many different ways to do this. We'll look at a few more in just a little while. But yeah, so you can crack passwords, many different types of passwords, password attacks, non-electronic, active online, passive online, and offline attacks. And I was just describing an offline attack. Let's look at some of these others. With non-electronic attacks, we have social engineering. This is the most effective non-electronic attack that you can do. It's convincing people to reveal information that they should. And here's why it works. Do you know that everybody you've ever met is running Human OS 1.0? Nobody has upgraded. Nope, it's all Human OS 1.0, not 1.1 or 1.2, right? So all of the features, I tell you what, Human OS 1.0 is full of features. Allows us to build skyscrapers and flying cars and SpaceX, all kinds of stuff. But it has its drawbacks in that we kind of like to be liked and loved and all that stuff that helps us make tribes and clans and cities and nations and stuff like that is great for social engineering. And that's what we take advantage of as social engineering. There are other types of non-electronic attacks. For instance, shoulder surfing. Shoulder surfing is when you just look at it. So looking at someone's keyboard or their screen, you could do this. Like there could be a building across the way, and you can get a telescope or binoculars and do it, right? Even from far away. So yeah, very cool stuff. Dumpster diving. Dumpster diving is where you go, and I was talking about that a little bit earlier, and get their trash. Get their trash. And use their trash for hacking their systems, right? So yeah, dumpster diving, and also dictionary attacks. And no, a dictionary attack is not where somebody throws a big heavy dictionary at you and you just barely duck out of the way in time. No, a dictionary attack is a file that is full of thousands of passwords, thousands of potential passwords, things like that. And we use that to try it over and over again in different combinations to attack them. Then we have brute force attacks. Now, brute force attack is one of the most difficult attacks. Here's why. Is because with a brute force attack, you try every combination of characters until the password is broken. Now, if you imagine a 20-character password, and the set of characters that are possible are 26 uppercase, 26 lowercase, 0 through 9, and all of the extra ASCII characters. It's a crazy large amount of a phase space to do. In fact, to break a very large password using brute force and current computing technology can take not only the rest of the time left in the universe, but you're going to have to start up a couple of extra universes and run them out too. And I tell you what, I usually don't like spending that much time just trying to break a password. All right. So now what I want to say about that, though, is we're entering a new era. And we don't talk about this as much in the CEH because it's really not that much of a thing. But right now, you can go to IBM. They have their quantum computing services. You can sign up for an IBM quantum account, and you can learn how to program for quantum computers, and very low level stuff, very easy to do, and submit jobs to the quantum computer. It's just a few qubits. Eventually, we'll have 1024, 4048, 2048 qubit quantum computers. And as they get bigger and bigger, eventually they'll be able to crack passwords with brute force almost in real time. No age of the universe needed, basically real time. But we don't have to worry about that for maybe 15 years or so. But right now, brute force is only something that works with small passwords and large resources. Rule-based attacks. Let's say that I have an account, an organization that has accounts, and the account is the employee ID number dash and then some password. That is a rule. So if I can know the employee ID number, I have a big chunk of the password already. So I can just use that rule for the attack. Password guessing only works in the movies, or maybe if you're trying to remember your password, it works, but it's hard to do that. Failure rate is very high for password guessing. And there's another one too. This is what I always in my classes introduce my students to, this 4-letter word. This is a curse word. It's called default. Default. Yeah, I know it looks like it has more letters, but it's a 4-letter word. We don't want any defaults. Why? Because anybody can hack something that's based on default usernames, default passwords, default accounts, any defaults. In fact, try this. Open up a tab in your browser, go to DuckDuckGo or Google, whichever, or you can even search in Yahoo if you want. But go to your search engine and type in default passwords. Type that in. You will see that you'll get a list from some sites like cert.net, defaultpasswords.us, and others. In fact, if it's Google, right at the top of your search, you'll see some of them in a site, and these are the default passwords for everything from Cisco to D-Link to HP to AD, any type of software or hardware that has come with a default username or password setup, you can find it right here online. So if somebody sets up something with a default username or password or default accounts, you just walk right into it. Very easy to do. Another one is the idea of keyloggers, Trojan, spyware. So what you can do is you can use a keylogger to track every single keystroke that someone does, or spyware to spy on them. Sometimes this is wrapped around or distributed through some type of email or text or something like that, that entices a user to click. This is usually the downfall of all users, is they click on it. Don't click on it. Don't touch that link. Other types of active online attacks are pass the hash. Pass the hash is a type of injection. You inject a compromised hash into the session. So you already know what the hash is. You're the attacker. You've compromised it. And then the user logs in, making use of that compromised hash, and then the attacker has complete control over it. So pass the hash, there's more to it than that we talk about in the class, but that's one of them. Now, this is a really interesting one. This is LLM&R MPTNS poisoning. And with LLM&R MPTNS, link local multicast systems with NetBIOS. And what this does is when you go to a share on a Windows server, and the way you go to a share is you type in whack whack and the share name. Whack means backslash. So if you think, if I say whack whack and you're like, is that guy trying to be a duck or what? No, that's just how you say backslash without having to say all those silly syllables. It's just whack. So whack whack. And then this guy's doing DTA server, some type of data server. What'll happen is if responder is running on the network, this user will get an error. And they'll say, oops, I couldn't find that, sorry. But what it'll do is take the NTLMv2 hash from that user's login and dump it. So see right here, the hash is dumped, and then from there we can crack it. Let's try that. That should be fun. All right, so I think we have enough time to try this before the top of the hour break. Oh, by the way, I want you to know that at the top of every hour, we'll take a little bit of break. You can, this moves pretty fast. There's a lot of information. You might need to take your brain out and stretch it, relax a little bit by the time we get to the top of the hour. So we do take a break at the top of this hour and the top of the next hour. So just FYI, okay? If you need to go run and get coffee or whatever, you'll be able to do that soon. All right, so here we go. This is one of our labs. And right here, let's go to the previous one. Gain access to the system. Yeah, so this is the one we're looking at. Yeah, so perform active online attack to crack the system password using Respondar, right? So yeah, so let's try it with Respondar and see what we do. So this is a good opportunity to show you how these labs work. So first thing we're going to do, oh, by the way, what I always tell my students, and we're not going to do it, so because we don't have time. As I always tell my students, before you start the lab, read through the lab scenario. All right, so first you do that, then read the objectives of the lab, and then read the overview of the lab. And then after that, start the lab tasks. What I really don't want to happen in these labs for you as a student is for you to just start doing stuff and not have the big picture of what it is you're trying to do. If that happens, then you can easily get lost. You can easily not understand, why am I doing this? Why am I typing this in? What is this I'm typing anyway? It's good to get the overview of what it is that you're trying to accomplish before doing it. So one of the things you see here is you're going to be using LLM&R, which is linked local multicast name resolution, and MPTNS, which is NetBIOS, I was talking about before. the name service is how Microsoft, if you're running NetBIOS, sends information through a share, through in networking. Anytime you're in one of these labs, so if you take the class and you're doing one of the labs, anytime you see a gray box or a red box, you need to stop and read it. So this particular gray box gives us information about the IP addresses that we're using, which is very important for what we're about to do. So it says the Ubuntu box is IP address 10.9, and the Windows 10 is IP address 10.10. All right, got it. So now the first thing it wants to do is click on Ubuntu. Let's click on that, and that takes us over here to the Ubuntu box. So I put a check here because I did it. Now, if you take the class, your instructor will have access, if he wants to the backend lab interface during the class, but not afterwards. So let's say that I'm doing this and I get stuck on something during the class, and I say, "Hey, instructor, I can't figure out what's going on." The instructor can actually look at this interface. The instructor has access to that interface only during the class. In fact, so sometimes people are having lab issues and they'll contact me, but I can't see what they're doing, so I have to kind of figure out where they were with screenshots and so on. So anyway, we got to Ubuntu. The next thing we want to do with Ubuntu is click over here, and it wants us to log in with the password of Tor. So let's do that. There we go. There it is. Got it. So Tor. And now that we get logged in, let's wait till we see the UI, the user interface, the desktop. And then after that, we'll go to the Windows 10 box. So it should show up in a moment. Let me scroll up here. Scroll to, there it is. So now we're in Ubuntu. Oh, I want to say something about this. Do you have to know a lot about Linux to take this class? No, you don't. You should know networking and a few other things. They tell you about that before you sign up for the class. But will you know Linux after this class? Yes. So if you're not that good at Linux, you're not that good at Microsoft Windows Server networking, you'll get a lot better at it by the time you complete all these labs, by the time you do all the exercises. You're going to be pretty good with this stuff. In fact, there'll be pieces of software in these labs that you will have used so much that you can actually put it on your resume because you've just done it so much. All right, so now let's go to Windows 10. Yeah, all right, so with Windows 10, we're going to hit that Control-Delete. Just click right here to make that happen. And it's going to open up in just a moment. And when we go there, I want you to notice something here real quick. If you look here, it says click Jason on the left-hand page. You don't know how many times that I'll get an email or a call, and then there's a student who took CEH, and they say that the lab isn't working. The lab isn't working. So I go investigate, and I find out something like this, where they just clicked on an admin and logged in, rather than switching to the appropriate account. So always make sure you're logging with the appropriate account. Let's make note of the password that Jason is using. Look right over here. It says QWERTY. And by the way, that password is very, very secret. So I'm trusting you not to pass that on to anybody. We work so hard to make sure this is a password that just is unique, right? That's why you can roll your head on the keyboard and, and still get the password. Obviously, this is just a super easy password. The reason we're using it, though, is because it's easy to recognize, easy to use, and easy to hack. And that's what we're going to choose, practice hacking. Little sip of bulletproof coffee. All right, so now that we've got that up and running, which is what we're trying to do. There it is. We need to click yes here. Forgot about that. And so now we go back to Ubuntu. We're gonna bounce back and forth, and I don't need the software update, so I don't need that right now. So here in Ubuntu, we are going to need to open a terminal. It says, where does it say that right over here? It says, in the left pane under activities list, scroll down and click the icon to open the terminal window. So there are a lot of different ways to open terminal windows on Linux. One of them is right click, and usually there's an open terminal there. Another one is to go to activities and click and type in terminal. That's another way to do it. Another way to do it is to, we got out of there, is to, once you find a terminal, what I like to do, and what's fortunately it did for us, is they put it on the taskbar here on the activities bar. So we just click on it, makes it much easier. Just like it said, but I just wanted you to see there are many different ways to get in the terminal. And what we want to do now is follow this yellow brick road. So it says terminal window, type in CD responder. Let's look at another command real quick. That's the ls command. ls is kind of like, if you're familiar with the Windows command prompts, kind of like dir, dir, list out the directories. And sure enough, right here you see the directory responder. Also, for those of you who are not familiar with Linux, remember it is case sensitive. So responder with a capital R is different than responder with a lowercase r. So keep that in mind as you hack away at this lab. So I'm going to type in CD. CD stands for change directory responder. And by the way, I typed in capital RES and I hit tab. Whenever you're in Linux, for those of you who are not that good at Linux, tab complete everything you possibly can. All right, so you want to tab complete. Now that I'm in the responder folder, I type in ls, and there it is. See all those pys, .pys? Those are Python. Responder is written in Python. Right on. So, so now what I want to do is a very important command that you'll end up doing several times as you go through the labs in the CEH class, and that is chmod. Chmod is a command whose purpose is to modify the permissions on a file or folder. Mainly files we use it on. And what it is you see this plus X right here? X is for execute. And so what we're going to do is we are going to add execute permissions to responder.py so that we can execute it. So let's go for it. Let's go for it. Just want to explain. Some of you are like, Linux, Minix. I've worked with Linux all my life. Others of you are like, oh, wow, Linux. I really haven't used that. So I'm trying to strike a happy middle here. So what we're going to do now is chmod. And with chmod, we're going to do a plus X. And that plus X, we're going to apply that to, in this directory, locally, that's that / capital R responder.py. So what we're saying is find in this directory a file called responder.py and add, well, before we do this, let me do a Control C. And let's do ls-l. And let's look at responder.py right now, which is right here. Right, so the permissions that are defined are right there. And so what we're going to do is we're going to add execute permissions to responder if it doesn't already have it. So let's do that again. We're going to do chmod. Can barely see with these new contact lenses. And plus X / yeah, make sure I typed in everything correctly. It's hard to see from here. So it looks like it worked. Now what we want to do is tell responder which interface to use. So I'm going to do a sudo. Sudo means that we're going to run as an administrator. It stands for super user do. So sudo, then we're going to type in /responder .py -cap I ETH0. So what this says is, hey, responder, I want you to run. I want you to run. Go ahead and run. And I want you to send and receive information out of interface Ethernet 0, and that's going to want my password for, in this case, it's Tor. And there it is. So it says listening for events. See that right there, listening for events? Looking up here a little bit, it says responder. It gave me the nice logo and everything. So it's working. It's working. Now, what we want to do is go back over to Windows 10. In Windows 10, we're going to fake like we're an unsuspecting user, and we're going to attempt to get to this file share. So here we go. Type. I'm going to go over here and type in whack CEH-tools. Hit enter. And I get an error. There it is. See that error there? That is not real. The hacker did it. So now that we've done that, we're going to switch back to Ubuntu. And look at this. Responder has been busy. Pages scrolling, all kinds of stuff happening. So what we see right here is it captured the hash. Woohoo! That's what we were trying to do. And so what we're going to do is we're going to take our top of the hour break. We're going to find where responder puts the hash. And then we're going to crack the hash and find the password of this user. All right, but before we do that, we're going to take a 7-minute break. And we'll put 7 on the clock. We'll come back. We'll finish this hash, this hack. So 7 minutes. Take a quick break. We need to get some coffee and stuff. See you in 7. Tor, and which is root backwards. So now, as we saw when we left off, we had captured the hash of JSON. Yes, pretty soon we'll have to get rid of that mask that guy's been wearing. So by default, responder stores its logs in home responder logs. So what we're going to do is navigate to that and find the SMB file. So let's do that here. So we're going to go to the little Linux-looking file explorer. There it is, and there's a responder right chair. Double click on that, and you'll find, where is it? Scroll to the right here. Oh, under logs. Let's go to logs. There it is. SMB Intel MV2 SSP, etc., etc. Gives you the IP address that was captured. We found it. inside this little teeny file here, you'll find the hash in question. So we captured the hash. It's here with responder. All it took is somebody going to a shared folder file, and we found it. So we found that log file at step number 14. It says a log file appears, displaying the hashes recorded from the target system user as shown in the shot of screen. So we found it. It says close all the open windows. So we're going to close off responder, stop it from working because we already captured what we're looking for. Close terminal. And it says now attempt to crack the hashes and learn the password of the logged on user. His name is Jason. So to crack the hash, we're going to use Juan el Ripper, right? So Juan the Ripper, John the Ripper, I keep saying Juan now. John the Ripper is a really cool little tool, very easy to use, but it's not installed. And that's another thing I like about this is kind of realistic in that if I'm using Parrot Linux, which is over here, Parrot Security Linux, let's go ahead and log into there. If I'm using Parrot Security Linux, I have like 300 or more tools that are available to me. So I go to applications, I go to pen testing, and look at folders and subfolders and of major tools, and then programming tools and all kinds of stuff, right? But if I am in Ubuntu, it's just vanilla Ubuntu, and I want to do something like use John the Ripper, I need to install that. I mean, if I was going to use Responder, I might have had to install that. I mean, a vanilla version of Ubuntu is not going to have Responder on it. So in these labs, you get a lot of experience installing stuff on Linux, and then you get used to it, and then you can do it with your own Linux boxes in your own organization. But let's do this. There is a prepackaged version of this, and so what we're going to do is we're going to get over here. After completing sudo John. Okay, yeah, we go. Yeah. So okay, and in this case, we already did we not? I thought we had to install. I was pretty sure. Yeah, there it is. There it is. So right here, step number 17. In the terminal, we type in sudo and snap. Sudo snap. Snap is prepackaged install. Has all the everything we need. Install. And John the Ripper. And what it wants now is my password, which is Tor. And in Linux, when it asks you for the password like that, it doesn't show it when you type it. So here it goes. It's installing the whole thing. So John the Ripper will be done. And then we're going to go to step number 19, where we're actually going to use John that we've installed to crack that password. That was the last of the coffee. So my whole pot is gone. I'm not sure where it went. Yeah. But it's bulletproof coffee, so it's all good for me. No sugar. All right, there we go. So now we have John installed. Now what we're going to do is going to type in sudo again. Super user do, sudo. And that's John. And we're going to type in, and by the way, in Linux, whenever you type in a path, like you see here, tab complete everything. So I'm going to type in HO tab. I'm doing this path right here to the right. See this right here? Where the cursor is moving? Then U tab, capital R tab, L tab, and then that's the log file name, which is capital S tab. Yeah, that's it. Boom. Got it. So I hit enter and it starts to happen. Now I want you to know that this is an easy one. QWERTY? Are you kidding me? That's totally easy to hack. So if John's password were more complicated, would have to have more dictionary lists, would have to have more capacity and so on. But QWERTY was very easy, and as you can see right here, but Jason's password was easy. We got it. Easy like a Sunday morning. Yeah. All right. So that is how John the Ripper works, how Responder works. And so to prepare for the next lab, they tell you to close everything, go out to Windows and close everything. And says to sign out, because I think we need to sign in as another user for the next exercise. So I'll do a Control-Alt-Delete here and tell it to sign up. There we go. So this is how iLabs works. It's actually pretty cool. Get rid of that. And that is my demonstration. Bueno, so now what we're going to do is look at another area. And actually, we're continuing in this, looking at some of the other types of attacks, like internal monologue attack. This is another NTLM authentication attack. We have also for Active Directory in Kerberos. We have ticket granting, ticket cracking, both using ASREP roasting and also Kerberosting. I'm not going to go into all these in just a short time we have. But just to let you know that, you know how they used to say there's an app for that, right? You don't have to write your own methodologies for attacking Active Directory in Microsoft operating systems, because there is an app for that. It's called Mimikatz. Mimikatz is great for pass the ticket, pass the TGT, and other types of Kerberos ticket attacks. If you zoom in on it here, you see they're just showing you a session, and they're using a pass the ticket attack using Kerberos, using Mimikatz on Kerberos. There's also other tools like Rebios and Windows Credential Editor and others that can help with these types of attacks. There are also other types of attacks that we get into a little bit more when we're in the class, including Combinator, Fingerprint, Toggle Case, and Markov chains, but we don't have time to go through those today. There are also passive attacks. Passive attacks is when you're not injecting anything into the conversation. You're just doing it by listening. So in this case, the attacker has a sniffer. They're sniffing the wire, and they're using that to find plain text sessions. This is kind of hard to do because you have to be in the right place, the right time, and then you have to find that plain text information. We have also man-in-the-middle and replay attacks. Replay attacks are also hard to perpetrate. With a replay attack, you sniff the traffic in a wireless or wired network, and then whatever the user did to get access to that server, you replay it, and then you get access. Again, very hard to perpetrate. You have to be at the right place at the right time, and usually it has to be plain text traffic. But one that's a little bit more effective is rainbow tables. It's a rainbow of colors. Now, what a rainbow table is you take a dictionary, like a dictionary attack, a dictionary of files. You can take dictionary lists, brute force lists, and either way, what you do is you get the hash values of that dictionary, and then you run a really quick, based on the speed of your computer, comparison of those hashes to the hashes that you exfiltrated from the target machine. And that's easy to recover those pre-computed hashes, and you can hack in a machine using rainbow tables. We do it all the time. RTGen is a very nice little tool that has several parameters that you can use to generate a rainbow table with different hashing algorithms so that you can have a rainbow table. Now, you don't have to use RTGen. Just like I was telling you, you can find very large dictionaries online. You can go online and find gigabyte and terabyte size dictionaries. Now, you have to understand how big this is, because this is plain text. They're so big that it's very difficult to handle the file. Let's put it that way. These huge dictionaries, you can take them and convert them into a rainbow table by generating hashes for all the entries in the dictionary, or you can just go get the rainbow table. So when you're hunting for a rainbow table, you tell it the types of hashes that you're looking for. So if it's SHA-256 or SHA-1 or MD5 or NTLM v2 or NTLM or whatever, you find the hash you're looking for, and then you download the dictionary for that hash, or download the dictionaries that have a variety of hashes in them. And then you run your hack for it. Now, if you have a multi-terabyte dictionary or rainbow table, you know how long it can take to find the password in question? It takes a huge amount of computing resources. So there are a couple of things that you can do. Number one, you can distribute it using a DNA, distributed network attack. And you distribute it across a bunch of devices all over the network, combining their computing power, running it in the background. Or you can take the information and go to AWS, get yourself a monster machine with a huge amount of RAM, and also using graphic processors, and that processes very quickly. Or you can use a DNA algorithm on some powerful cloud resources and use it that way. So distributing the load. And there are tools that are very useful for password recovery, including Alchemsoft, distributed password recovery, password toolkit, Hashcat. Oh, I love Hashcat. Hashcat, THC Hydra. These work great on this Storm, the EC Council device that we have available. Password recovery tool, all kinds of tools out there. PW Dump 7. I love that one. Very good for dumping that SAM database. Again, Mimikatz comes up. Oh yeah, look at this. See, GitHub. I was going to say Grubhub. This is not, Grubhub is really not a part of this class, unless of course you're ordering pizza. Then it's a part of hacking. But GitHub, if you don't have a GitHub account and you're not familiar with GitHub, that's a good thing to get familiar with. As I go through my CEH class, one of the things that I highlight is some of the top tools and capabilities that you should get to know, right? So, and one of the things that you should have an account and be familiar with if you're going to be in hacking is GitHub. Right? So if you don't, you should, because you're going to be using it for downloading tools and working on projects and all kinds of good stuff. So Mimikatz is good. The PowerShell Empire, they strike again. DS internals for PowerShell. So these are tools that we use to extract password hashes. Now, the king of password hash cracking over many, many years has been Loftcrack, the venerable Loftcrack. Now, Loftcrack is a tool that these days professionals use it, right? It used to be a free tool, but now you have to pay money for it. So you only see professionals use it. It's still good though. I'm going to show it to you a little bit in just a little while here. But if you're low on cash, you can go get yourself some Offcrack. OPH Crack, Offcrack, is a Windows password cracker, and it uses rainbow tables. It's got a nice little GUI, graphical user interface. It runs on multiple platforms. Here's what you can do with Offcrack. You download it. You use Offcrack to burn yourself a DVD, burn yourself a CD, burn yourself a flash drive, or whatever you need to boot on. You boot on Offcrack, and then you crack the local Windows passwords with Offcrack. So it's worth a look at if you've never used it. Very cool stuff. And so now let's try it out. Let's see how LoftCrack works. We're going to do another little demonstration. Le démonstration. Allons, monsieur. Let me see if I can find my actual. I know I have a lab here somewhere. There it is. I found it. All right, so let's do some loft cracking. I'll pull out my handy dandy hacker keyboard and we'll crack away. All right, so so in this one, we're going to be on the Windows 10 box. Let's do a Control-Delete for step number 1. And we'll paste in the password. Bada boom. Hit enter. Now, I need to log in as admin, so I did it wrong, just like I warned. I'm glad it's a different password. That's very helpful. Should show up in a moment. Just clearing the screen. There it is. All right, we are in. Also, it tells you some alternative ways to log in. And it asks me if the network screen appears, which we already got that one. It would ask me if I wanted to allow this computer to be advertised on the network. I told it yes already. All right, I want to show you something here too. This is really, really cool. Check it out. Let's go over to Explorer, Windows Explorer. Still, oh, there it is. All right, so now what we want to do in Explorer is go to CEH Tools. And in CEH, check this out. See, for every module in the Certified Ethical Hacker, there is a collection of tools that you can use and install. I mean, for instance, if we go to module 9, social engineering, and then these are some GitHub tools. Shellfish, a social engineer toolkit. We go to module 12, IDS. We have firewalls. All right, so there's a Zone Alarm, and we have honeypot tools, and we have HTTP tunneling tools, post and host, and we have intrusion detection with Snort. So in some of your labs, you'll be installing these things, and that's exactly what I'm going to be doing here. So I'm going to go over. The reason I brought this up is because what we do is we package up a huge amount of these tools, not every one of them, but the majority of them, and make them available to you as a CEH student through a login area we call Aspen, and you can download these tools to help build your own lab. That's what it's about. So now what we're going to do is we're going to head over to module 6, system hacking, and in module 6, we're going to go to password cracking tools, and in password cracking tools, we're going to go to LoftCrack, and in LoftCrack, we're going to run the install. Here's LC, and then tell yes. We minimize this while it's installing, and we'll run the install. And if you look at the lab here, it says to hit next, 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 and it says to if it asks me to, it says to keep the check in the box that says to run LoftCrack, and then click finish. So let's do that. Next here. Okay, let's read the license agreement. You ready? The license file. Got it done. Very nice. That was an easy read. I like the character development. That was just, wonderful. And then we hit next. And then we have a check in the box that says run LoftCrack. Boom. Hit finish. All right, so now we've finished step number 5. Step number 5. And we'll go to step number 6. It says the LoftCrack right there, 7 trial pop-up page appear. Click proceed with trial button. So we go down here. to proceed with trial. Woohoo! All right. Got her. So it says if an update is available, ignore it. So now we go over here to where it says, click on the password auditing wizard, and let's do it. There we go. We're now in the password auditing wizard. So what I always tell my students is while you're in these interfaces, make sure and read them. So normally, like I would want my students to stop and read through this introduction, but no tenemos, we don't have enough time. So let's just keep on rolling here. And there's an introduction. And let's see what it tells us to do next. It says hit next. And it says to do, choose Windows. There it is. So there's Windows chosen. We hit next. And let's see, does it do the local machine? No, it says to do a remote machine. So we do that. And then we hit next. And do we just hit next? No, we have to fill this out. So, so let's get this filled out. The first thing we're going to need is the IP address of the target machine, and that's going to be 10.10.10.16. That's the Windows Server 2016 machine. All right. So now it says to use specific user credentials. So we have to supply some creds. And over here, you'll see it says we use administrator with password of capital P A $, W0RD. So let's try it out. Administrator. I actually have to type it in correctly. All right. And then from administrator, we type in capital P A $, W0RD. All right. And then from there, we type in the domain, which is ceh.com. And let's see what else it says. It says that I'm going to look at this. Check it out. Clicked on the screenshot, and I can check and see if I have everything I need. And there it is. I did it correctly. It looks like to me. I love the screenshots because if you have anything that you're not so sure about, you just look at the screenshot and you can tell whether or not you did it correctly. So in this case, let's hit next. And then it says, do I want a quick, a common, or a thorough? So in this case, it tells me that I want a thorough assessment. If you look at the strong assessment, it can take days. That's a lot. That's too much time. Me don't have time for that. So it says to click on next after thorough. And then from there, it says that we have the reporting options. We'll put a check in here and have a CSV report. And it says to browse and go to my worst favorite place to put information like this, but it's easy to find for a lab. I'll put it on the desktop. So we save it there. And then once doing that, we hit next. All right, and then job scheduling, run this immediately, and we hit next. And then step number 18, we hit finish. And there it goes. LoftCrack is we're running it away, cracking passwords. You look over here, let's see how it's doing. I'm scroll down here. And oh, it found Martin's password. Martin's password is Apple. Shame on you, Martin. You could have done a better password than that, for sure. Anything else? It found the administrator, capital P A $, It found Jason's QWERTY. So LoftCrack is cracking away. It's doing a great job finding all the passwords on these systems. So very nice. LoftCrack does it again. And that's why professionals like to use LoftCrack. So after successfully doing this, what we'll find, I'm going to just put checks on the rest of this because I'm really finished. What we'll find is underneath LoftCrack, minimize it. On the desktop, after it's finished, there will appear a little link to the comma separated value file that I can use to import this information into other tools so that I can use that information, like for instance, in a pen test report or something like that. Isn't that cool? Right on. So let's take that out of the way. So as you can see, these labs are no joke. They're actually very, very nice. They're easy to use, easy to understand, but they give you hacking street cred if you learn how to do it. And it teaches you how to do it, which is very, very nice. Oh, I really like this stuff. So that's our demonstration. So password cracking tools that you can use to crack passwords on systems, Rainbow Crack using rainbow tables, and it uses a time memory trade-off algorithm to try to crack them as fast as possible. We already saw John the Ripper in action. I already mentioned Hashcat and THC Hydra, very nice tools, Medusa. These are all password cracking tools. And if you don't want somebody to crack your company's passwords, then you have to pull out a little bit of salt, right? Salting the password, what it does is adds a few extra characters to the end of the hashes so that you can't easily reverse the hash and find the password. So the only problem is, though, is you can't do that with Windows passwords because they have to have backward compatibility with a huge list of older operating systems. So what you want in order to protect your passwords on Windows is syskey, S-Y-S-K-E-Y. If you want to look that up, and the word SAM, syskey and SAM, you'll find that you can find instructions on how to syskey your SAM, making it much less likely that anybody will be able to dump those passwords. If the SAM was syskeyed, Loftcrack would probably not have worked. All right, so we have defending against password cracking, and I want you to know that at the ends, towards the ends of every section, because this is really on a class on how to be offensive. Oh, do I offend? Offensive. In other words, you're on the attack in the Certified Ethical Hacker. However, we're not just being offensive here, because we have to learn how to defend our systems too. So there's a little bit of defense in here also. And so you'll see that there's a list at the end of every section telling you how to defend against the thing they taught you how to perpetrate, how to be offensive. There are several different areas that we find are repeated very often. The first one is to use encryption. So whether it's data at rest and you're encrypting files and folders, or whole disk encryption, or it's data in transit where you're encrypting data like through a VPN or SSL or HTTPS or something like that, or even encryption of data that's in use, which is much more difficult to do. So encryption is one thing that helps defend against a lot of the attacks that we do. The other one is identity. So I can use Active Directory or other identity services to do things like multi-factor authentication. So you have to have a username and password. Then you have to present a dongle or a CAC, which is a kind of card we use in government services in the United States, or some other type of something you have, or biometrics, like a iris scan or a thumbprint or something like that, right? So number one is encryption. Number two is to have good identity services. Number three is to test it yourself. right? See right here, use an information security audit. So before your code, if you're a programmer, you're a developer, before your code goes out the door, it needs to be tested. Before your website is published, it needs to be fuzzed, tested, pen tested, gone through the ringer, so that won't happen with the bad guys. You don't want the good guys doing that, not the bad guys. All right, so those are some of the things that you often see. You don't want to store password. Oh, there's that 4-letter word. Look at that. Default. Ew. Don't want any defaults anywhere. We want to use long pass phrases, syskey or SAM, or salt your other passwords. Don't use anything familiar in a dictionary. And I'm not going to go through these lists of things that you can do because we don't have time to go through each one of them. But I will hit this one, which is, again, this has to do with identity again, which says to create a BIOS or UEFI password so that someone can't just grab that machine and boot to the BIOS and then take it over. Righto. Also, you want to disable LMBNR, which is that link local multicast name broadcasting, and you do that with group policy. You turn it off for every computer in that domain, in that entire area. The next thing we do is we need to fix networking. Now, there was a time, if you happen to have NT4, Windows 2000, or Windows 2003 in your network, you have bigger problems. However, you won't be able to follow this advice that we're going to give right here. Right? For the rest of us, if you have Windows versions above that, you don't need LM hosts, and especially for what we saw with Responder, you don't want to have NetBIOS over TCP/IP, so you want to disable it. LM host, disabling that will provide a little bit of extra security, but that's not the main thing. For disabling LM host, by taking the check out of that box, you make your network a little bit faster, because otherwise it's going to look in, every time it does a lookup and it can't find it, it's also going to look in your LM host file. If you're familiar with the host file, the LM host file is like a host file for Microsoft. Both the host file and the LM host file are in the drivers, C:\/32 whack drivers whack etc, and you'll find them in there. So quite a lot to think about. Also, go check it out. Find out on your network, is there some attacker that's running a listener for LMNR and BTNS? You can find that out by running Vindicate. So it looks for not only LMNR and NBNS, but also MDNS spoofing. Try to detect those. And then we also have got responded. They should put a question mark there, like got milk, right? So got responded, again, helps look for LMNR and BTNS spoofing, and it even uses the same format in terms of the logo and everything as Responder does, even though it's the opposite of Responder. And you can see it says spoofing detected. You can actually detect that stuff. You need to run it on your network. Make sure no one is gathering your passwords and hacking them RN right now. All right, so another thing that we want to do as attackers is find vulnerabilities and exploit them. How do you do that? Well, there's a lot of ways you can find vulnerabilities, but one of them is to use a Google hacking database. Let's have a look at the GHDB. All right, so let me go grab myself a browser. I'm gonna get onto this thing we call the internet. If you've never heard of it, here will be an introduction for you. Just kidding, of course. Oops, I spelled it completely wrong, but hopefully it'll get me there anyway. I was trying to type it sideways. There we go. All right. This is a GHDB, or the Google Hacking Database. Let's let it load up. The first thing that we find when we get to the Google Hacking Database is a bunch of dorks. No, really, look, see, these are all dorks. Right now I have 150 dorks loaded up on the page. What a dork is a Google search. And the purpose of the Google search is to find user interfaces and protocols and passwords and services that are wide open, exposed on the network. This is one I haven't seen before. Look, this is actually pretty new. This is really cool. This is one to find pages containing portals. So these are from multiple vendors. Let's see what I see here. I see ZWall. Oh, they're all, it looks like there's ZWalls and VPN 100 and many others. Wow, that's pretty cool. Man, I want to try that. Let's try that out. See if we can find any. Ah, very cool. So this is an exposed Zyxel interface somewhere. Let's try it out. Why is it exposed? Well, somebody either accidentally or on purpose installed a Zyxel ATP 500, and the interface is available on the internet. So what I would do next is I would type in default that's going to be a ZYXEL. So get the default password for it, if there is one. Run that search through DuckDuckGo. So here's the, this is the actual PDF for Zyxel ATP 500. It's the user manual. It's the man page. Password changing procedure. So anyway, I'm not going to spend time finding all this out. It may not have an easy default password, but it gives me, right there, I have a manual for this thing. Another thing that I could do is I could check it for injection. So for instance, I could try for SQL injection, try for code injection, stuff like that, right? So that is the, that's one of them. Let's find another one. Let's see if we find one. There's a lot of them out here. Let's go to search page number 7. This is Access Blue Login Blue Cloud Shield. Oh, interesting. Where is this? This looks like it's in UK, but it looks like it's in Japanese. Oh, I'm not authorized for that one. I got busted. All right, let's try it again. Let's go to the Bernini Studio. I have no idea what that is, but it looks like it's an exposed web login. Bitdefender says I shouldn't, so let's not go there. Let's go back. Let's go to number 3 here. I have no idea what this is. So this looks like a USG 310 login. Let's see if it really is. No, it's Russian hackers trying to get me. Try this one. It's VPN in Italy. Is it real, or is it an attack page? Oh, it's an attack page. They're trying to get me. They're trying to sucker me in. They're trying to get old Kevin. Take down my system. There's another ATP 500. Try that one. Where's this one? This is IXON. Oh, that one is also fake. All right. So anyway, at least we got one good one from this dork. It takes a while of looking around. So how would I use this dork? What I would do is, let's say that I have routers and firewalls and servers and all that kind of stuff. And let's say that maybe I have something that runs with HP. Let's type in HP. And There's HP. This is mainly PHP. Let's do Dell. That's more unique. And so here's Dell SonicWall and Authentic. And let's say that I found that people can find my SonicWall authentication page right there on the internet. I might want to rethink how I'm doing my security. Right? I want to go to the drawing board and do it differently, because if a Google Dork shows it, then that means anybody can get it. Right? So looks like Google's onto me now. Let's try this one. Is Google onto me? Are they going to try to ask me if? Yeah, they're onto me. They think I might be a robot. No, I'm just teaching a hacking class. It's hard to recognize traffic lights when you're a robot. All right, let me in. All right, they didn't find anything. Yeah, Google didn't like my series of searches. All right, so now check this out. Now we're going to go over to the real. Here's the real thing. In the exploit database, we find actual exploits. What are these exploits? These are well known. These are proven exploits. In fact, if I am running a SonicWall firewall, SSL VPN 8.0.0.0, there is a known exploit for shell shock, allowing the attacker complete remote code execution. This has a red X by it, which means it hasn't, the code to run the attack hasn't been verified by everybody. But there's an exploit. Here is the actual code written by Darren Martin. And it goes in, look at that. Very nice ASCII art and everything, and all the different definitions and so on. So what I can do is I can go, there are many different ways to run this code, but the bottom line is very likely that I will be able to, if I find a firewall with that exact version of SSL VPN, I own it with this exploit. Let's find another one here. I'm going to change my show to 120 here. Let's go way down here and we'll look at this is Gila. It's a WordPress. So there's a WordPress plugin. It's a custom global variables 1.0.5 dash some name. And in this, if you find anything with this exact reference, you will be able to do a stored cross-site script, which means you'll be able to take an arbitrary chunk of code and store it on that page. This one's been verified, right? Here's the actual code. He's part of it. If I want, I can download the exploit. And this is some of the exploit here, just telling you how to do it. And you're in. Very easy to run arbitrary code if somebody is using this exact version. This is why we scan systems. And then I find that that system is using a WordPress site. So I scan further to find out what plugins they're using. I find that they're using custom global variables 1.0.5. And like, really? Man, they should have updated that, because now I can do what I want with this. Now, I can't run arbitrary code that would allow me to hack into it, but I can store stuff on there to hack other people. So, wow. So the exploit database is our common vulnerabilities that we can use. There are shell codes in here. There are searches here. There's all kinds of stuff in the Google hacking database. And you can just go to it whenever you want. Easy as cake. All right, let's keep going. We have to get to a bunch of stuff before we get to the top of the hour and take another break. Buffer overflow. You know what a buffer overflow is? Every app. So if you run a program, the program has a has a process, at least one process. What is a process? A process is an execution thread, at least one thread that makes use of memory, space, and CPU that's been allocated to it. That thread of execution for that process has allocated a certain amount and certain location for RAM, random access memory. And what happens with a buffer overflow is there's an area of adjacent memory to that allocation that we can cause that thread of execution, that program, that app to overwrite its memory locations that have been allocated to it. And you can inject malicious code into the buffer, you can damage files, you can crash the app, you can modify program data, get access to critical information, get a shell, do privilege escalation, and it's all because of poor coding. They didn't check their boundaries. They're using old versions of programming language that when you compile the program, it compiles with buffer overflow errors, unsafe variables, unsafe functions. They're not using good programming practices. Whenever you're dealing with apps, you must use secure coding. Very, very important. So buffer overflows are things that can happen. And we teach you about buffer overflows, samples in C and so on, and even tools to help you detect a buffer overflow. So what an attacker is going to do, scan your executables and use tools like OllyDog, Veracode, Flaw Finder, Splint, and others to find vulnerable programs, vulnerable DLLs, vulnerable binaries, and then execute a buffer overflow attack. This is why, as network and system engineers, as ethical hackers, as network defenders, we need to do this ourselves on our own systems to determine if or if not our apps are vulnerable to a buffer overflow. Many ways to defend against buffer overflows. I also want you to know too that during a good chunk of the class, a lot of the defense side of things tends to get into very technical programmatic things. So for instance, if I am a network or a system engineer, I'm not going to worry about ASLR. I'm not going to worry about address space layout randomization. Why? Because I'm not the developer. I am not the one who is running this. I didn't write it. One moment here. We're going to pause just for a second. All right. So, but the developer is going to need to know that he needs to run address space layout randomization. Also, with at the system engineer level, you can implement the site with data execution prevention, DEP, right? You can do that at the server level. But others of these are some of these like code inspection. That's really going to be at the developer side. Patching regularly, that's going to be at the network system engineer administrator side. So we have things that are going to be handed out to each part of the team. All right, so now what we're going to do is we're going to talk about escalating privileges. We're not going to get through all of these today, but we'll at least get through some of it. With escalating privileges, we'll look at some of the methodology for doing that and some really crazy things that can allow you to escalate privilege and gain access, and maybe a little bit of demo with that. All right, so let's take our top of the hour break. When we come back from our top of the hour break, we'll get into escalating privileges. So I'm gonna put 6 minutes on the clock. 6 minutes ought to do it. And we'll come back. We'll do web access, privilege escalation, demos, and stuff like that. So take a quick break. All righty then. So what we're going to do is we're going to look at some privilege escalation. So just as a reminder, with privilege escalation, very often when you are attacking a system, you don't get what you want right away. So for instance, you might end up with a guest account. You might end up with a user account that just barely doesn't, it might not even be a domain account. So let's say that there's a system that you hack into. You have a local user account, but it doesn't allow you to access any domain information. You need more. So as an attacker, you need to expand your operation and go into privilege escalation. There are two major types of privilege escalation. One is horizontal and the other is vertical. Now, when most people think of privilege escalation, they think of vertical. Horizontal is when we take it from having a, let's say you have a user account, and we move it up to an administrator account or a root account. That is vertical. Excuse me, that's vertical. Horizontal is when you get another user account. But that's not bad. Here, check it out. What if the other user account that you get is also a system administrator or a database owner on a database server? In that case, not bad. It might work just fine for you. So either way, the way that you escalate privileges is you take advantage of bugs, implementation errors, configuration issues, design flaws, application misconfigurations, things like that. Just installing an application improperly, using the wrong credentials, wrong services, things like that, can cause trouble. Now, another way to do it is by hijacking a DLL. Do you know what DLL is? DLL stands for Dynamic Link Library. I want to demonstrate for you what a DLL is. What I want to do is I want to show you a program. This program is one of the most used, to this day, one of the most used applications for web programming, and that is Notepad. All right, so here's Notepad. Virtually everybody has used Notepad before. Notepad has some notable features. Let's look at some of the features of Notepad. Number one, we have menus. Almost every single Windows application, not even just Windows, but almost every single application you'll ever use has file menu, has edit menu, format menu maybe, especially if it has a writing app or something like that. View menu and help menu. And in the help menu, we're going to always have some type of about where you click on it and it shows you a splash screen about that app. But wait, there's more. You're also going to have horizontal and vertical scroll bars. Now, imagine this. You're a developer. What do you do all day? Program stuff. How many programs do you write in a year? Let's say it's 20 different programs a year. That's kind of a lot, but maybe it's your whole team that puts out 20 different programs a year. On every program, do you really want to uniquely code the title bar with the minimize and maximize and restore and close buttons. For every program, you want to put in all that code yourself. What about the file menu? All 20 of those programs have a file menu. Do you really need to code all that every time you run a program? No. So what you do is you use a library. So if, let's say I'm an organization that makes scientific programs, and one thing that appears in a lot of my programs is an equation editor. And once I code a very good and very stable equation editor, then what I can do is I can store it, that code, in a library, a dynamic link library. And then from my app, my scientific app, I can say call EQlib, right? So that's my equation library, and I can put it right in there without having to code it. If I need a file menu, I say call file_menu from the DLL. If I need a horizontal scroll bar, I say call h_scroll from the DLL. If I need a vertical scroll bar, call scroll vscroll from the DLL. So rather than rebuilding every program from scratch, all the stuff I need, I just call from a DLL. So that I stop there to tell you about this so that you can understand the importance of DLLs staying safe. So what an attacker can do is an attacker can misassociate a malicious DLL with an executable. So the executable says, hey, I want to call the h_scroll bar or the whatever. It goes to the malicious DLL where there's bad code and maybe a new button is added at the time it's called. And a user clicks on it and it runs the code or whatever. There's so many things you can do with DLLs. DLLs have huge amounts of code libraries in them many times. So it's very important to make sure that you are not falling prey to DLL hijacking. And so what you'd want to do is you'd want to run a tool like Robber. What Robber does is it's an open source tool that you can use to find executables that are vulnerable to DLL hijacking, right? So you can use that to find that type of stuff. Very, very helpful when you're looking at that. And just for your information, we're sort of running out of time here, so let me just show you about that. We'll close Loftcrack. Still running, so sorry, but that's all we have time for, Mr. Loftcrack. Says an operation's in progress. Okay, I need to stop the operation. Let me do that first here. Click on stop. And then I'll close it. And no, I don't want to save it. Did it give me my report? I don't see my report. I think I stopped it too early for the report. It should have showed up though. All right. So here's what I wanted to show you is that for privilege escalation, some of the exercises that we have make use of several different things. One of these is we're going to do, there's a tool called broot. Remember I told you about that? There's an exercise where you're going to use broot to escalate privileges. Run a little Metasploit interpreter shell here. And over here, we have another exercise. There's broot right there. Let's go down to the end of this exercise. Wish I had time to take you through the whole thing. It's amazing stuff. Another one is using Metasploit to perform post-exploitation using Meterpreter. So Metasploit, you run it. I usually try to assign the Metasploit labs because it's so such a great tool. You can use MS Venom and set everything up and run it. And so lots of tools and exercises that you can get used to escalating privileges. And then you want to maintain remote access, hide your malicious activities. And so yeah, all of that's around. I'm going to log out of this lab, and hopefully I'll have time to do one more demo and cancel this lab. And I'm going to load up one more. And hopefully, what time is it now? Yeah, I think I'll have time to do one more demo. Just need to go back and grab the one I'm looking for. Make sure it's the lab I'm looking for. So a lot of people think this. Hey, I'm really not that vulnerable. I run a Mac, right? So I run Mac, iOS. So I'm not really that concerned about these types of hacks. Sorry, Macs are also vulnerable. If you look here, first of all, if you go to the vulnerability database, you will find that there are Macintosh hacks available. There are Apple hacks available. And you'll also find that there are DILIBs. A DILIB is a DLL, but a DLL on a Mac. So it's a Mac DLL, which is really cool. So how would this work on a Mac? How would this work? What you would do is you would get somebody to click on something or smuggle in some type of flash drive or other type of method to carry that information in, and then you can hijack a privilege escalate on a Mac using DILIBs. So my point here is that just because you're on a Mac doesn't mean you're invulnerable. It just means that you're on a machine that has much less market share than Windows or Linux, and therefore is attacked less often. But you'll find some crazy hacks for Macs. There's BRoot right there. You saw that. We have that available in the lab. There's LintoStep. This one is a little tool that has detailed information on the kernel, used to escalate privileges, and then we defend against that. Many different ways of doing that. Some of the top areas I was talking about before with updates and so on. Very good to have around. Also, you can take a tool, and by the way, this is one you can download. It's a very nice little tool. I love it. Dependency Walker. What Dependency Walker does is it looks at your executables. Let's just zoom in on it real quick to make it easier to see. And looks at your executable and it shows you all of the DLLs upon which your executable depends. So you can see all these dependencies. Also, there is DILIB hijack scanner. And DILIB hijack scanner will scan your computer to determine if you're susceptible to DILIB hijacking. So if you have a Mac, you can scan that computer and find out if that Mac is vulnerable or not, and you might find vulnerabilities. Either way, you want to defend against those. There are one of the biggest things you want to do is regularly update, and there are a bunch of other things that you can do that are very nice to have. Another tool would be Inspector. This is not for DILIBs, but rather this is something that is useful for Spectre and Meltdown. Are you familiar with Spectre and Meltdown? If you have an x86 computer system, you are vulnerable to Spectre and Meltdown. So it's a good time to double check and see if you do, if you have those vulnerabilities. Also, for executing applications, once an attacker attacks your system, what they're going to want to do is run applications like keyloggers, backdoors, spyware, crackers, and just a few of these things. And just look at this. This is sort of amazing here. We have, if I click on my Windows key on my keyboard, and I type in SCH and hit enter, I will have the task scheduler. Bring it over here. And because the apps that I've installed, there are tasks that are scheduled to run. Task Scheduler is a tool that administrators use regularly. We used to use this. You write a little script to do maintenance on systems. You push it out to all the systems in the task scheduler, and then the script will run maintenance whenever you tell it to. It's like a schedule, a timer, right? So that's task scheduler. It's just a tool that we use all the time. But like I like to tell my students, any system or network administrator tool is also a hacker tool. And task scheduler is no different. So what an attacker will do is they'll run their script or their code, and the purpose of which is to, at a certain time, like a logic bomb, run their malware. And they'll use your task scheduler to do it. But not just task scheduler, also WMI and WinRM. WMI is Windows Management Instrumentation that has very powerful back-end access to all of the major Windows and minor Windows subsystems. We use this all the time for scripting. But like I say, any system or network administration tool is also a hacker tool. Also WinRM. WinRM is really nice because with WinRM, I can run something in the context of a local user, but remotely. I can do the same thing with PowerShell, PS remoting. And that makes it very powerful. I can run a script and it doesn't look like it's coming from way across the network. It looks like it's running locally with WinRM and PS remoting. And these are remote code execution tools and techniques. There are a lot of them. If you've ever worked in a help desk, second level support, first level support, one of the first things you do, a user calls up and says, yeah, there's something strange on my screen. I don't know what it is. It looks like a little blob or something like that. And he said, well, let me have a look at that. And then you use remote exec, or you use Dameware or some of these tools to get a desktop, and you look at their desktop. And you say, oh, that blob. Yeah, that's just, you know, a video that you accidentally clicked on or whatever, right? Or that's ransomware. Oh, no. Whatever it is, you can see it remotely. And there are all kinds of Puppy, PS Exec. These are tools to remotely execute stuff, to get to remote desktops, and so on. And these are ways, tools and ways that attackers use to attack your systems. And really, these are all built just for plain old system administration. All right, keyloggers. Have you ever heard of a keylogger? I bet you have. What they do is they take advantage of the fact that you can pull every keystroke off of the kernel for Windows and Linux or any device, really. There are hardware keyloggers and software keyloggers. A hardware keylogger is one that you plug into the back of a computer system. If you think about a bunch of computers in a cubicle, how often do people check the back of their computer system? So let me show you how this looks. I'm just trying to find a little picture for you. That's too small. So what the attacker does is they pull out your computer system. This can just take a few seconds. Unplug your keyboard, plug in the keylogger to USB or even PS3, and then plug your keyboard back in. Put your computer back where it was. No one knows the difference. So now everything you type on that keyboard gets recorded in the keylogger. Now, with a keylogger like this, it's very possible that the attacker will have to come back and remove that keylogger. And then what you do is take the keylogger, you plug it into one of your USB ports, you do a special series of control characters, and then you put in a passcode, and then you can read all the text that's been collected in the keylogger, every password, every keystroke, everything that the person types. Now, to make things worse, sometimes the thief, the attacker, doesn't even need to come back by and pull that keylogger from the computer system because it's Wi-Fi. So it connects to the Wi-Fi network, and you can grab that information from the keylogger anytime you want. Or it's Bluetooth, and all you have to do is get near that keylogger, and you can dump that information. So again, ask yourself, how many times, how often do users check the back of their desktop computer systems that are hiding off in a corner where it's hardly ever moved? And that's why they can stay there for so long. But not only that, there are software keyloggers that you can put on a system. So these are the hardware keyloggers. All kinds of different vendors make them. Then there are keyloggers for Windows. These are software keyloggers like Spyrix, all-in-one keylogger, Elite keylogger, Spytector keylogger, all kinds of keyloggers for Macs. Yeah, so you think my system's unhackable, but yet it has a keylogger in it. Someone is watching everything you do. And then there's spyware. In our lab, we have a really cool one showing you how to use a Spytech spy agent monitoring everything a user does on a computer. This is legit software. This is not just for hackers, although hackers use it. Attackers use it. It's so that you can monitor employees in an organization. Power Spy, recording all activities. Oh, and children. Desktop child monitoring software. If you have children, you know what I'm talking about. One thing I told my kids is that as long as you live here under this house, all your passwords, all your accounts, and all you don't have any privacy, right? I routinely spy on the kids because they're did you know that kids are born dumb? They really are. And you have to educate them and teach them and train them. It takes so long to program a kid. In that process of programming the kid, you have to spy on them these days. We also have USB spyware and audio spyware. Turn on the microphone of the device. Video spyware, turn on the camera and record what's going on in the room. Cell phone spyware, turn on the microphone and the camera and get all their data. I find that especially for cell phone and GPS spyware, the X is the primary one doing this kind of stuff. The X sends you a text with a link, you click on it, and next thing you know, you have some spyware installed on your cell phone. I've seen that happen before. Mobile spy, this stuff is great for GPS. You get this on someone's system and you can see everywhere they go. Mobile stealth, flexi spy. A lot of these pieces of software have GPS and other capabilities. So yeah, you can be spied upon. There are a lot of things to do to defend against keyloggers. One of the main things that I want you to look into is running your own detection. Check and see if you have a keylogger on your system. If you so desire and you have access to it and it's not a problem for your computer, run over to Google or DuckDuckGo and type in Zemana anti-keylogger. There's a 30-day trial. You can download this little guy and run this keylogger detector and see if you actually have keyloggers on your system. It's worth it. There are others too, like Ghost Press and Key Scrambler and the Spy Shelter free anti-keylogger and others. But if you don't want to install new software on your system, what antivirus are you using? Go to your antivirus, your anti-spyware, antivirus, anti-malware, excuse me, and find out in a Google search, find out if it has anti-keylogger, if it has anti-rootkit, if it has anti-spyware capabilities. Just do a search, find out. Because if it doesn't, you might want to go to a new piece of anti-malware software, one that does better than the current one, right? And by the way, I do have to say this now and then. Windows Defender is not good enough, right? Just get that out in the air. Windows Defender is not good enough. Windows Defender is to antivirus like WordPad is to writing books, right? Or maybe like Notepad is to Word. It's not enough. You really need to have another more sophisticated piece of software writing on top of it. And there are a lot of reasons I can tell you about that. Go to YouTube, for those of you who are only running Defender, and look up a video on testing Windows Defender. And you'll see what I mean. It's gotten a lot better. I really have to give kudos to Microsoft. It's gotten a lot better over the years, but still not as enough. It's not enough. All right. So, all right. So, rootkits. What's the objective of a rootkit? Let me show you something. I'm going to do a Control-Shift escape, and from Control-Shift escape, that brings me to my task manager, and I'm going to go to details in my task manager. And in details, I can see every single process ID from 0 all the way to 47,678, 768. That's a lot. If there is a rootkit, that process will not show up. I won't see it anywhere. I won't see any section of it, any hide, any hair of it. Nope, nothing at all. Won't see it. It is completely hidden. Rootkits are very difficult to detect because of the way they hide. Now, one thing that we do in the CEH class is we give you the capability to discern the types of rootkits, find them, and we also show you how to use them, right? So rootkits, very important. You can defend against them in many different ways. I'm not going to go through the entire list here for the sake of time, but there are some tools that you can use. A Gimmer is nice. A Stinger has been around for a long time, and I really like what they do. McAfee owns them these days. And another one that I really like is Avast. Avast, one of my favorite things about it is it has a very easy ability to run a boot time scan. That's what you need to discover rootkits. You're not going to stop a rootkit without rebooting, because what you have to do is you have to run the scan before the operating system loads, because after that, the game's over. Avast is very good for that. So find out if your antivirus, anti-malware software can easily do a boot time scan, and what it has available to defend against rootkits. All right, I want to show you something that's pretty amazing, and that is NTFS. You know what NTFS is, right? NTFS is the file system that Windows uses. So it's the file system. So if I format a Windows 10, a Windows Server 2016, a Windows Server 2019, if I format the drive, I'm going to be using NTFS. Here's something crazy that can happen in Windows NTFS. It's called alternative data streams. Have you heard of it before, ADS? What happens is I can take a file and tuck it away into the file system where it doesn't show up. If I do a scan, if I look for it, I can't see it. If I look for that size, if I put 10 megabytes in it, it won't show up. This is how you do it. Check it out. So what I do is I go to a prompt, sort of like this, and I can tell it C:, whack. Actually, from here, I just do a notepad. So normally if you type in notepad, it opens up notepad. But if I want to create a file, it's new file .txt, and then I create a fork. So if I were to hit enter on this, a notepad would open up to new file.txt. You won't see hidden file.txt. It's an alternative universe, an alternative data stream that hides that file information. So you see that right over here, where we've done it with both lion and tiger.txt. So if I put 10 megabytes in lion.txt and I put 10 megabytes in tiger.txt, and in my file.txt I only put a kilobyte will show up, not 20 megs. So I won't even see those files. Now, if I want to put information or read those files, I have to include that colon and the alternative data stream. So let's talk about how that can be used dangerously. So here's what happens. Somebody writes malware, right? Trojan.exe. So see this word here, type? What that does is it displays the information on the screen. What this does, this is a redirection operator that looks greater than, redirects that display instead of coming out to the screen to put it into not readme.txt, but the alternative data stream, Trojan.exe. So I'm dumping the executable contents into an alternative data stream executable. All right, so that's bad enough. Now I can use mlink. What mlink does is it allows you to link file system locations into things like text files and Word files or whatever. So you can click on a link and it takes you, like I can have a Word document and click on a link and it opens up Explorer and takes me to a location. That's called mlink. So with mlink, I can take an executable in the file system called backdoor.exe and link it to Trojan.exe so that if backdoor is run, Trojan runs. All right, now I sit around waiting for something to happen. Oh, here it is. I type in backdoor, or maybe I put this command into Task Scheduler to run at 3 a.m. every morning, and then I can get up at 3 and hack into that computer system automatically because there's a backdoor or something like that. And if anybody scans the computer system, all they see is readme.txt. Cray, right? It's crazy. So you want to make sure that you don't have streams. There are many different ways to do it, but there is an app for that. Stream Detector, Stream Armor, Stream Detector, Gimmer, ADS Scanner, Streams, all of these can help you detect streams and stop them on your computer system. All right, so I just want to say a little bit about steganography, and then we're going to move on to web applications. Steganography is hiding information in any cover medium. The cover medium is virtually any kind of file type you can imagine. So most people, when they think of steganography, think of image steganography, where you hide something in an image, often using LSB manipulation. That's a least significant bit, where you use the compression algorithm in images, audio, video, all those types of, you can use the compression algorithm to hide stuff in there. You can hide it in any one of these mediums. Why? Let's say that an attacker is in my network. They got into my HR systems. They found all my employees' social security numbers, or they found all my customers or clients' information. Now they need to get that information out before someone discovers them on the network. So what they do is they exfiltrate that data. One of the ways to do that is by steganographically encoding it and then shipping it out of the network. All right, so those are ways to do it. There are other ways to do it, by the way. And now what we're going to do is we're going to switch things over a little bit and talk about web application hacking. I tell you what, this is a very important part of hacking because so much of what we do on a daily basis is web applications. So this is one of the most important modules that we do, web application hacking. And one of the things I want to show you, there are 5 different areas we talk about. We really only have time to talk about one of them, and barely at that. But one of the things I want to show you is how a web application works. Web application has multiple tiers. At the very bottom, we normally have the database. In the middle, we have objects that are written to take commands from the top level application and run them in the database. Typically, with a database, you'll see something like select star. This is a structured query language, or SQL or SQL statement that says, I want you to read from the news table where this ID is. What we do in the this section, we look at our web application architecture and we explore ways that you can take all these web services from SOAP and REST and take advantage of that vulnerability stack and hack web applications. What we find is that the OWASP has identified 10 major areas of web application vulnerabilities. And in the class, we go through each one of these. But I want to look at one in particular, which is injection flaws. Now, I've already mentioned SQL injection or SQL injection, but there are other forms of injection, like, for instance, command injection. With command injection, the attacker can put in whatever arbitrary code they want and have it running on somebody's website. With LDAP injection, the attacker can add and remove users from directory services, change passwords, change attributes of user objects, account objects, group objects, depending on the level of access that they've been able to do. All of those can be injected into a, for instance, a URL, or also into a form, a web form, and in many other ways. So look at this little message. So let's say that I'm in a web form. See right here, it says test, tick, and then it has a left paren. I'm sorry, that's a right paren, and then a semicolon. That's the end of this. And then it says drop table messages. That semicolon says that's the end of this message, and anything else that's in this entire SQL statement, I want you to consider it to be a comment. You're not going to run it. So now I put that in a web form, and the database deletes the table, just drops it. Boom, it's gone. These are the types of hacks that somebody can do. We can inject shells, so we can get a shell on a system, or embed HTML, or inject files, redirect to an entire different site. It's just an example of that, where somebody is taking something that should be one format, and instead they're adding code to the site. And it's their own code. It's arbitrary. They can do whatever they want. All right, so let's have a look at how that works. Go over here. Retry the connection. Having connection issues here. See if it works. While it's coming up, I want to show you some of the web hacking scenarios that we have here. So we go to lab 1. And in lab 1, we just start off with footprinting the web server. And what we do here is we find out, having connection issues. Don't even know if this seminar is still connected, frankly. But what we do is you find out, I'm going to just quickly go over here and run a speed test. Oh, am I even on the internet? Let me just check with my team and find out if I'm still even running this. All right, so I'm going to assume I'm still up and running because I don't have any errors from my GoToWebinar. But suffice to say, we have quite a number of labs that are really good in walking you through how to run each one of these types of hacks. So it's great to have them around. Like for instance, a file injection hack. There's LDAP. See this LDAP here? What the person is doing is they're modifying, they're using LDAP to get logged in for free without even having to know the password. We have other types of injection. Look at the whole list of different types of injection that we have with injection attacks. So a huge number of types and styles of injection. What we find in the end is that there are a huge number of web application threats out there. We have threats from directory traversal. So directory traversal is when a web server is running out of a folder, the website is running out of a folder on the web server. What we can do is we can go from that folder with a .. methodology to move higher and higher into the hierarchy until we get to the root of that system. That's directory traversal. We can go grab cookies, cookie snooping. It sounds like what someone does in the kitchen when they shouldn't be in there. And take the cookies that the user is using and take advantage of those and use those to grab sessions, to hack web applications, and many others. Also, there's buffer overflow. Also, there's a watering hole attack. A watering hole attack takes advantage of the fact that very often in a given organization, users visit specific sites most often. So what the attacker will do is scan the location, and from there, the attacker will find out what let's say the top 20 most used sites are. And then from there, they will find which one of those are vulnerable. And if there are any of them that are vulnerable, they will put a trap in there for the users who are visiting those sites most often. Right. So some of the tricks that they use are, for instance, cross-site scripting. With cross-site scripting, and I don't see that, I know that's here somewhere, but with cross-site scripting, what you do is you put in a piece of code, and if anybody goes to that page and clicks on something, the code runs. And there are so many other types of attacks on web services, on the DMZ protocols. Like for instance, if you have a DNS server in your DMZ or an HTTP server in your DMZ, those can be attacked. There are clickjacking attacks where the website drives you to click on a malicious link or item in the website. And many other types of attacks And what we do in the CEH is we take you into each one of these attacks, showing you what they are. And then for specific types of attacks, we also take you into the labs so you can practice those styles of attacks. And then you can take those back to your place of employment, and you can use those to, in the end, defend your network. So many, many types of threats that are available. All right, well, that brings us to the end of the CEH first look. And what you see is there are just a huge number of opportunities to learn what it takes to be on the red team. So you can learn the same types of hacks and attacks that real world hackers and attackers use, so that in the end, you can use those to defend your network. And so, so that's what we have for today. Look in the email that you got in response to getting hooked up with this session, and you can contact people that can help you with sales, help you with discounts, get you hooked up to become a certified ethical hacker. That's all we have for today. Hope you have a great weekend. Stay bold out there, and we'll see you out there hacking away. Take care, everybody. Have a good evening.
Thank you, Kevin. It was a really wonderful time spent with you, and hope everyone enjoyed this session, and it was very informative for everyone. And please make a note, there will be no recording for this session, and we'll be not going to provide any certificate of attendance for the first look sessions. So hope everyone will understand the same. So you're speaking to Anil, the event organizer. So we'll be going to meet tomorrow at the same time for CND first look session. Thank you very much.